Hello again, Statistics and Precalculus, still on Safari looking for the graphs of square root functions, which you saw last year, but it may have been a while. Let's see if they are still around in the wild, waiting to be observed. Let's take a quick look. Graphs of square root functions. First off, we're going to do a squared function to create the square root. This is y equals x squared, and it is transformed by moving down 3 units. That's not something that should be a challenge for you. We'd start with 0, 0 goes down 3 units. How about 1, 1? It goes down 3 units, and the equivalent one on that side. 2, 4 going down 3 units would be 2, 1. 3, 9 going down 3 units would be 3, 6, and on that side. Now, however, if you did the whole parabola, it is not a one-to-one function. So we cannot, if we take the inverse is not a function. So we're going to restrict it. Only take it over the domain, only take it over the domain 0 to infinity. Only the right-hand side of the graph. And now it is a function. So now we can graph the inverse. This is using the points 0, 0, 0, negative 3. 0, 0 went to 0, negative 3, 1, negative 2, 2, positive 1, and 3, positive 6. If we're finding the inverse here, the inverse is going to have the points neg 3, 0, neg 2, 1, 1, 2, and 6, 3. Neg 3, 0, neg 2, 1, 1, 2, and 6, 3. There is the inverse. You notice it's got a lovely reflection. It's the reflection over the line y equals x. Like any graph of any inverse, the reflection over the line y equals x looks very nice. The equation of that inverse. The equation originally is y equals x squared minus 3, so it's x equals y squared minus 3. Add 3 to both sides, and take the square root. Y is the square root of x plus 3, but it's a plus or minus situation when you take a square root. If you had y squared is 25, you have two answers, 5 and negative 5. Y equals plus or minus the square root of x plus 3, but we only have one of those. How do you know? This original version was looking at x is greater than or equal to 0. So that means on the inverse, we want y to be greater than or equal to 0. And you see that that's what we have on the graph. Y is greater than or equal to 0. So that means for the equation, we will use the positive version. Y equals positive the square root of x plus 3. That's the inverse. F inverse of x is positive the square root of x plus 3. And you'll notice that looks like the square root function moved to the left 3, and sure enough, it is a squared function moved to the left 3. What about the bottom half of that parabola, the left-hand side? We can take another look and see where that goes. Going to take a look at the left-hand side this time. Start with the same parabola. 0, neg 3. Neg 2 plus or minus 1, neg 1 plus or minus 2, and neg 2, 1, and 3, 6, and negative 3, 6, dot, 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 dot is the graph. But we were looking at the negative side this time for the function. We're looking at the places where x is less than or equal to 0. So we're looking at the points 0, 0, neg 1, neg 0, neg 3. I did it again. 0, neg 3, neg 1, neg 2, neg 2 and 1, neg 3 and 6. So on my inverse, I'm looking at neg 3, 0, neg 2, neg 1, 1, neg 2, and 6, neg 3. 0, neg 3, 0. Neg 2, neg 1, 1, neg 2, and 6, neg 3. We're looking at that half, and you see that it is indeed the reflection of the other one. So the equation of the inverse in this case, still x equals y squared minus 3, still add 3 to both sides, and take the square root. but it's a plus or minus again. Plus or minus the square root of x plus 3. And in this case, since on the original, x was less than or equal to 0, on the inverse, we're going to have y is less than or equal to 0, so we want the negative square root of x plus 3. There you go. And we will look at that reflection in a minute when we look at some other graphs. Good. Notice the right side, the left side, when you put the purple ones together, you get the entire parabola. When you put the red ones together, you get a reflected parabola. So it's the two halves of the parabola in purple, the two halves of the sideways parabola in red. Yay! Take a look here. We have a dilation. What are the we've got a square root function and we're doing a lot of stuff to it. Dilating vertically by 3. And we are also moving that. We are moving that left 2 and down 4. So we're good to go. On the original parent function, this is doing the same thing with a square root function that you've done all year long, and in fact in previous years as well. The parent function 0, 0, 1, 1, 4, 2, 9, 3, all those lovely points that fit on the graph that have good, nice integer coordinates for the square root function. So that's your parent function. And now, we always do dilations first, so let's dilate. Multiply the y's by 3. That means the x's are still 0, 1, 4, 9, and the y's are now 0, 3, 6, 9. So the y's have been multiplied by 3, and now translate, and we'll go left 2. If we go left 2, my x-coordinates will be -2, -1, 2, and 7. If we go down 4, my y-coordinates will be -4, -1, 2, and 5. So there we go. Let's graph this baby. This will look like, let's find a good color. This wants to be orange today. Can I change the thickness? No. Too bad. -2, -4, -1, -1, 2, 2, 7, 5. And there is your transformed function. You notice that it's stretched, and you can definitely see that stretch. You also notice the domain and range have changed. The domain is now x has to be bigger than or equal to -2. Or -2 to infinity if you're writing in interval notation. The range is that y is bigger than or equal to -4. And again, if you're in interval notation, -4 to infinity. Whew. One last thing. The reflections of square root functions can be a bit challenging. So take a look at the reflections of square root functions. Going to reflect over the x-axis, the y-axis, and both. Starting off with y equals the square root of x, our parent function. We know all these points. 0, 0, 1, 1, 4, 2, 9, 3. There's the parent function. The one in green is a reflection over the x-axis. The y's become negative. So if we started with these points and make the y's negative, it's still 0, 0. It's 1 and -1. It's 4 and -2. It's 9 and -3. So you've taken the square roots, you've made them negative. The one in blue, it's a reflection over the y-axis. The x's become negative, and that's sometimes a challenge to think about mentally because you're used to it saying I can only take the square root of a positive number. Well, it's true, you can only take the square root of a positive number, but if x is a negative number, then the opposite of x becomes positive. Suppose x is -4, then opposite of negative 4 is 4, and we take the square root of 4, which is 2. So negative 4, 2. The same point reflected. You take that point 4, 2, and reflect by making the x negative. And then the square root all works out. And also, if x is negative 9, square root of negative 9 is not defined, but negative of negative 9 is positive 9, and the square root of positive 9 right there. So we have that one. You can guess where this fourth one is going to go. You've reflected over the x-axis, reflected over the y-axis, and the x-axis, or you could do it in the other order, the x-axis and then the y-axis. You go down to the down to the third quadrant, 0, 0, neg 1, neg 1, neg 4, neg 2, neg 9, neg 3. Just to check, that was not nice. Just to check on those points. If you plugged in, for instance, negative 9 for x, you would have negative of negative 9, which is positive 9. Take the square root as 3. Take the opposite of that is negative 3, and there we go. So we have these. Y equals negative square root of negative x down in this quadrant. In the second quadrant, wrong color, in the second quadrant, y equals the square root of negative x, so the y's are positive, the x's are negative. In the first quadrant, the original, y equals the square root of x. And last but not least, I don't know why you did that, last but not least, in the fourth quadrant, y equals negative the square root of x. And now you can switch over if you want to, but I guess you're not going to. Have yourself a lovely day. We've got reflections of square roots, only cube roots left to go, and we're in pretty good shape even though it's only Tuesday. Take care.